Now the question is, okay, they are storing the beginning address of the MICM info because there only the structure starts. So we have 6422.303 as the result, right? So now the question is whether these two signals are stored in a same memory location or in a consecutive memory location. That we have to inspect. Maybe it may also store in 304. The break switch request can also be stored in break switch 304. No, that can also happen, right? So what I am going to do, I am going to individually print their address of each data member. So for that we can use this. This cannot take address of a bit field. Okay, they are automatically throwing that as an error because we cannot disclose that. They are packing them in a single bytes now. So this says we cannot do it. Right. From this to understand that they are using the consecutive memory location, they are not using consecutive memory location. I am doing another trick. After this, I declare a variable here call int char unsigned char and yes I am here equal to C. If I get C after in the memory location next to ICM info, then it is stored in the consecutive memory location only. So these two signals are stored in the same memory location. For that, what I also do, I declare a pointer. I think we can directly print the address now. Char C, unsigned char C equivalent to capital C. Then we will print the address of that. This will help us to determine they are using a single byte to store those two signals. Oh, okay. Right. So now, right? Okay, I made a address of C. So it is the next memory location. From this, what we address of C. From this output, we get two things. This structure is allocated in the stack memory. That is one thing. Then these two signals are stored in a single memory location 6422.303 because only then they can assign the next memory location to C. If they have assigned one byte for these signals, this will get 301 only. It cannot get the next consecutive memory location. That is not possible. Right. As it is stack, the last variable that we pushed appeared at the first place. Right now. So everything works fine. So now you are clear, right? How we can pack different sets of bit in a single byte. You can declare the CAN packets like this. When you are developing a embedded CAN module, right? In that, all CAN packets should be declared in this fashion. Does that make sense? Understood? Any doubt? Amir?
Yes, sir.
Clear answer.
Sir, in embedded domain, so for the message set, we are using the structure, sir,
Oh,
for
see,
creating. Yeah.
this is like you are developing this programming is used by the developer. See, at a real module, we have electronic module that we have now. For that also, they have to write program. What we had seen in Python course that we had is a testing side. If a testing engineer want to declare a packet, we have a method. We have a library, can dot message like that we are declaring. If a developer want to declare a packet that he want to use it in his program, how he used to do? He will do like this only. Make sense?
Yes, sir.
Shall
Then
we?
what are like other use cases? Main other use cases?
We are going towards that step by step. Slowly we'll go there, and then
Okay.
we'll start programming real embedded module as well right now.
Okay,
So
sir.
this is the one thing. In banking programming, we have the structures are used everywhere to store the student records. The student records, we have some details like their age, date of birth, marks, like that. They can create a structure for that. That is in for that is one sort of domain, application domain. That is general purpose software development domain. They use the structure in their way. When it is come to automotive, they use the structure for their purpose. So here structure I have represented using CAN because which is very used in the embedded automotive domain. You don't think that only the structure is used for creating CAN packet. Don't assume like that. If you want to pack more than one data in a single nutshell to store them in a consecutive memory locations in RAM, then you can go for structure. So that is required when we work with CAN packet, we are doing it right now. Okay, moving forward, this is like accessing structure member using dot operator. We can also create a structure pointer. See, I want to have 10 instant of a particular packet and want to navigate between each instant. Let's say I have a for ICM info collection. I want to declare an array now. For that, what I can do is I don't want to disturb this. What we will do, collection of ICM info packets. I call that as COL collection. As it is collection, it should be more than one. So I have some 3 instant of my ICM info. After that, I also create a structure pointer. Right. If I declare a integer pointer it will jump 4 byte per increment. If it is a structure pointer, what is the jump size? Amir.
4 bytes only answer. It stores just address.
So you mean to say 4 bytes each, because you mean to say structure is also an integer, because it will jump 4 bytes every time when I increment the structure pointer. Actually, it is not. The structure pointer increment is based on your definition of your structure. In this structure, we have packed 2 signals in a single byte. Right now. So when I declare a structure pointer using ICM info structure, it will increment. When I increment it, it will increment 1 byte every time. If I have something like this, additional int temp, an additional variable. So this is 1 byte, this is 4 byte. Every time 5 bytes, when I increment the ICM info pointer, it will increment 5 bytes. If I have additionally a float, let's say it consumes 8 bytes, 8 plus 4, 12, 12 plus 1, 13 bytes, it will increment every time when I increment a structure pointer.